Section 2 is titled the quadratic formula, and I imagine a lot of you are familiar with this. And if you're not familiar, it's not particularly hard. The quadratic formula is this formula that's written on the screen. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula is a formula that can be used to solve quadratic equations. A quadratic equation is an equation that has a trinomial to the left of an equal sign, highest exponent 2, and it's set equal to 0 on the right hand side. So if a problem has three terms, a trinomial on one side of an equal sign, 0 on the other, and very specifically, if the exponents on the variables are 2 and 1 and you have a constant, then you can use this problem to solve the equation. On the next sheet I wrote up an example. Let me just show you how to use this quadratic formula to solve an equation that's written in the form that's desired. Maybe I'll do a couple of these. So this equation, we could solve it by factoring like we did in section 5.8. I probably couldn't solve it by square rooting plus or minus square rooting because I don't see a parentheses with a squared and I see a couple of x terms. But this problem is set up perfectly to solve with the quadratic formula. It's set equal to 0. It has three terms on one side of the equal sign. It has a second power term, a first power term, and a constant. When that's the setup, then you can look at the coefficients and assign letters to them alphabetically. The number in front of the x squared term without the x itself is the a for the formula. The number in front of the first power term without the variable is the b. And the constant is the c. The quadratic formula is very particular. It doesn't work when we have exponents like x cubed or x to the fourth. It doesn't work if there's any factoring in the problem. It only works when you have three terms, a square term, a first power term, a constant on one side of an equation written as a trinomial set equal to 0. To solve this problem using the quadratic formula, which is really a nice way to solve the problem, I'm going to form a giant fraction, and in the numerator I'm going to get a negative sign from the formula, a plus or minus sign from the formula, a squared and a minus sign, and a 4 from the formula, and in the denominator a 2. These are all the parts of the formula that are the same every single time. That minus sign, that plus or minus sign, the square root symbol, the square, the minus, the 4, and the 2. All of those, regardless of the problem, those are going to be constants. The variable parts are going to change from problem to problem. And in this problem, in the numerator of my fraction, the variable I'm going to put in is b. And because it's negative, it's safe to plug it in a parentheses. Going under the radical, the first variable I need to plug in is the number 15. After the minus sign, after the 4, I need a times c, and I usually do the parentheses for times. So a is going to be 5, c is going to be 10. Almost done, but in the denominator I need twice a, and a is 5. So this is the beginning of solving a problem using the quadratic formula. I would get the same answers if I solved by factoring. When I'm working with the quadratic formula, I generally like to get steps. If there's a double negative in the numerator, I naturally just enter it as positive. So I'm going to make that double negative in my numerator positive. I can simplify the denominator and the numerator separately. That 2 times 5 in the denominator, I could make a 10. That's the stuff I can do mindlessly. Anytime I see a double negative, I'm free to make it positive at any time. I can simplify a fraction's denominator separately from the numerator. After I get that cleaned up, I'm going to work on getting a single number under my square root. Generally, I use my calculator because I make less mistakes on my calculator than I do working by hand. So I just entered what I have on my calculator, and my calculator tells me this is 25. Real careful, students, when they're working the quadratic formula, do bad things because they don't know they're bad. And I'll show you in a bit here a common mistake that students will make in reducing too early, or reducing when it's illegal to reduce. And let me finish up the problem and leave myself room to tell you that common mistake. So, square root of 25, I'm going to continue reducing. That's a perfect square root. I don't need a calculator for it. Just like in section 6.1, when we have a problem with a plus or minus, if there's no I nor square root after the plus or minus, I should make two problems up. And so I'm going to make the two problems up that are implied here, which is 15 plus 5 over 10 and 15 minus 5 over 10. The 15 plus 5 over 10 is 20 over 10, and that's equal to 2. That should be one of the answers to this problem. The 15 minus 5 over 10 is 10 over 10, and that's equal to 1. I claim that these are the two answers, and of course, anytime I solve a problem that has an equal sign, I can check. So let me go ahead and check both of these just because it's the first version. And then I'll go back and show you a common mistake and show you that that doesn't check. And then maybe I'll do a problem that has the potential for that same common mistake. So I'm going to first check x equal to 1 and see if 5 times 1 squared minus 15 times 1 plus 10 equals 0. So 5 times 1 squared plus 15 minus, really struggling this morning. Shocking how many mistakes I've made. Scrubbed this video already, or deleted it. Whoa, what did I do wrong? Let me enter this again. Oh, I don't know. Crud. 5 times 1 squared minus 15 times 1 plus 10. And that gives me a 0 equal to 0. That checks. Similarly, if I do the 2 and do 5 times 2 squared minus 15 times 2 plus 10, the only way that answer is right is if I get 0 again, because the right-hand side is already 0. And when I'm checking, I'm just trying to make the left side and the right sides equal each other. So I'm mindlessly plugging these numbers in, and I'll show you that they both check. So I didn't make the common mistake, but so often students will do this. They'll say, oh, I look at this 15 over 10 reduces, and they'll do this. They'll say this is x equals to 3 plus or minus the square root of 25 over 2 by dividing both of those by 5. Let me make the square root of 25 into 5. And let me show you what answers you get when you do it that way. You would get x equal to 3 plus 5 over 2, and x equal to 3 minus 5 over the 2. This would give me x equal to 8 over 2, and x equal to negative 2 over 2, which would give me x equal to 4 and x equal to negative 1. I'll check both of them and show you neither one of them checks. If I do 5 times 4 squared minus 15 times 4 plus 10 to check the 4 by plugging it into my original problem, I'd get 5 times 4 squared minus 15 times 4 plus 10, and that would give me 30 equal to 0. So 4 is not a solution. Similarly, if I worked on the negative 1 and did 5 times negative 1 squared minus 15 times negative 1 plus 10 and see what that equals, it would have to be 0 for my answer to be right. But it gives 30 again. So when I'm reducing for the quadratic formula, it's illegal to reduce the denominator with just the number to the left of the plus or minus sign. I made up another example that it's not on my handout. I actually made it up by mistake because I was shooting this video and I made a mistake, and it was a good mistake in that it allowed me to show you how to reduce something like this. But you can't reduce the denominator with just the number to the left of the plus or minus sign. So this is not from anywhere. This is just an extra problem. I'm going to solve using the quadratic formula. So I'm going to write the quadratic formula down. And I made this problem up accidentally. X squared plus 10x minus 10 equals 0. And let me solve this. In this problem, the a is the number that's implied in front of the x squared, which is 1. The b is the number in front of the x, which is positive 10. And the c is the constant, which is negative 10. So I'm going to shove the numbers into the formula. In the numerator, I start with a negative sign. If the b is negative, I put it in a parentheses right in front of that, after that negative sign. If the b is positive, that parentheses isn't necessary. Under the radical, it's always good to put the b in a parentheses. It's a good habit to get into so you don't forget it when it's actually needed. So I get b squared, which is 10 squared, minus 4, and then for a 1 and c negative 10, and then in the denominator twice a. So I can simplify the denominator quickly. The denominator just reduces to 2. And then under the radical, I see 10 squared minus 4 times 1 times negative 10. And I get 140 under the radical. It would be illegal to reduce this. Let me show you what it reduces to. What I'm striving to get is this. I can't do the plus or minus sign, but I can do this. I can go negative 10 plus the square root of 140 over 2. My calculator tells me I should get this. I should get negative 5. And then I'm going to change the plus sign to a plus or minus sign. I can't do the plus or minus sign on my calculator, but I can throw it back in. I claim that's going to be the best answer for this. And I'll show you how to get it. Let me be lazy and reduce the square root of 140 to save some time on my calculator. The square root of 140 is 2 square root of 35. So I can rewrite this problem as x equals negative 10 plus or minus 2 square root of 35 over 2. If you have a big fraction like the quadratic formula creates, the only time it's legal to reduce the denominator with the numerator is if it goes evenly into the number in front of the square root and to the number to the left of the plus or minus sign. Those three numbers I have are all reducible by 2, so I'm going to reduce them. I'm going to go negative 10 divided by 2 is negative 5, 2 divided by 2 is 1, 2 divided by 2 is 1. What I have now is negative 5 plus or minus 1 square root of 35 over 1. And that's equal to what my calculator gave me because I don't need to write the 1 in the denominator. If fractions with 1 in the denominator aren't necessary, you can just write the numerator and you don't need a 1 before the square root. The common mistake on this, which would cause you to get the wrong answer, is to reduce too early when it's illegal to reduce. When I had the fraction as negative 10 plus or minus the square root of 140 over 2, if you would reduce too early, if you reduce the left side of the numerator with the denominator without reducing it with the right side, you'd get negative 5 plus or minus the square root of 140 over 1. I don't need to write the over 1, so you'd get negative 5 plus or minus the square root of 140. And the square root of 140, that's 2 square root of 35. For an answer, you'd get negative 5 plus or minus 2 square root of 35. It's not quite the right answer. This is the biggest trick when it comes to the quadratic formula, is knowing how to properly reduce the denominator with the numerator when you can't reduce and when you can reduce. You can reduce the denominator with the numerator only if it goes evenly into the number to the left of the plus or minus sign into the number in front of the square root. You can't reduce when the number in front of the square root doesn't divide the same way with the number to the left of the plus or minus sign. And in this version, there's a negative 10 that reduces with the 2 to the left of the plus or minus sign, but the 1 to the left of the radical doesn't reduce with the 2. So this is all wrong. It's an error. It leads you to the wrong answer doing that reduction. Let me just start jumping into some problems because the video is already getting some serious length to it. And I haven't even done one problem. So let me just start. And I'm going to probably have to skip through these, maybe do every fourth, and it should be adequate. So problem 2 is where I made a mistake and had to redo the video, but I think it was a fortunate mistake. In problem 2, I look at the coefficients, I look at the problem and make sure it's written in a good order. The good order is a trinomial, written in standard order, first term with a second degree, second term a first degree, last term a constant. That's a good order. So now I'm going to plug the numbers into the formula and write x equals big fraction with a plus or minus sign. The numerator leads with a negative sign. If the b is positive, I don't generally put it in a parentheses in front of the plus or minus sign, but if it's negative, I do. Under the radical, the first thing I need is b squared, just to be safe, because it's not always needed, but it's often needed. I'm putting the b in a parentheses. The b is really only, parentheses is only really needed when the b is negative, but if I start putting it in parentheses sometimes and not on the other times, somebody's going to make a mistake that they shouldn't make. So under the radical, I'm just always going to put the b in a parentheses. Now, I can simplify the denominator to 2 and get the square root down to a single number. So under the radical, I have 10 squared minus 4 times 1 times negative 11, and I get 144. If the square root disappears completely, I shouldn't have a plus or minus in my answer. If when I reduce the square root I get an I or a square root, I'll leave the plus or minus in my answer. But because in this problem the square root disappears completely, I shouldn't have a plus or minus in my answer, and I should make up the problems that are implied by the plus or minus. This is a reducible fraction. Let me go ahead and reduce it. It's going to make my life easier. If the number in the denominator goes evenly into the number to the left of the plus or minus sign and in front of the square root to the right of the plus or minus sign, or to the right of the plus or minus sign if there's no square root, all those numbers are divisible. I'm going to go negative 10 divided by 2 and get negative 5. 12 divided by 2 and get 6. 2 divided by 2 and get 1. Don't have to do that, but it's going to make the work easier that I'm about to do, because now I can set up my two equations that are implied by that plus or minus sign and get the answers that I need to get. One of my answers is going to be positive 1 because negative 5 plus 6 is 1. The other answer is going to be negative 11. And I'll box those and write them how I normally write answers. Three and 4 are good problems because it's one of the tricks. Usually when I do the quadratic formula, I expect to get 2 answers, but sometimes I can just get 1 answer, and that's going to happen in both 3 and 4. Let's just do 3 together. So I'm going to write that quadratic formula down, which is negative b plus or minus the square root of b squared minus 4ac over 2a. Since this problem has 3 terms, it's set equal to 0, it's a squared, a constant, and a first power term. It's eligible for the quadratic formula. So my a is going to be 1, my b is going to be positive 6, my c is going to be 9, and I'm going to write x equals, and then negative sign from the formula. Right here, if b is negative, I put it in a parentheses. If it's positive, the parentheses absolutely not needed. And then some more stuff from the formula before I get to the b squared, which I'm always going to put in a parentheses, even though the parentheses is really only necessary when the b is negative. So I finished up putting the a and the c in the numerator, the a in the denominator, just plucking off the formula. And I instinctively reduce the denominator right off. It would be illegal to reduce that negative 6 with 2. Let me see, under the radical, I see 6 squared minus 4 times 1 times 9. Under the radical, I get 0. But this is a special problem. And the square root of 0 is 0. When you get a 0 under the radical, you only get one solution. Because the problems that are implied are x equals negative 6 plus 0 over 2, and x equals negative 6 minus 0 over 2. And adding or subtracting 0, you just get the first term. So the negative 6 plus 0 over 2, as well as the negative 6 minus 0 over 2, both give the answer of negative 3. In college algebra, we would say the solution of negative 3 has multiplicity 2, or even multiplicity. That's getting too complicated, but it's something that happens. So my answer to number 3 is just x equal to negative 3. I'm going to skip, no, let's do 5 and 6 because they have ugly answers. And they have I answers, and there's a preference for I's. So let's work on 6 again, and then we'll do a part 2. So I'm going to do negative b plus or minus the square root of b squared minus 4ac over 2a. The a is the 1 that's implied in front of the squared term. The b is the negative 3, and the c is the 5. So I'm going to write x equals negative from the formula. B is negative, so out in front of the radical I put it in a parentheses. Under the radical I'm always going to put b in the parentheses just to be safe. In the numerator, I have a double negative out in front of the radical that I could make positive. In the denominator, I can make the 2 times 1, 2. Now under the radical, I'm going to get it down to a single number. That's negative 3 squared minus 4 times 1 times 5. The underside of the radical comes out to minus 11. And I can definitely simplify that by giving myself an I. While this is a correct answer, it's not the standard form for an I answer. If the numerator comes out to have an I, it's customary to break the fraction from a single fraction with a plus or minus in the numerator into 2 fractions with a plus or minus between the fraction. And even more than that, it's customary to drag the I off to the right. All of these are going to be equal to each other. When I enter this on my calculator in a second, when I enter the top version on my calculator in a second, because I'm going to be in mode 2, it's going to show you that it wants that version. So i's, you usually make separate fractions. Let me make sure I'm in mode 2 and do the fraction 3 plus the square root of 11, arrow out of the square root, hit the ENG button for the I, go down to the denominator and put 2. That's that without the minus sign. My calculator doesn't have a plus or minus button. And when I hit equals, that's the form that it likes. I'm not married to that. If you left it there, that would be fine. This is considered standard form when we have an I. This is something called a complex number, which we didn't get into at all. But that's the preferred way. As you get higher in math, you'll get teachers that really, really like standard forms. And so it's good to see those and get used to those. All right, I'm going to pause. We're going to do a part 2. And in the part 2, I'm going to skip because I didn't skip any problems yet. And I don't want this to be a 3-part video.